Good afternoon, everyone. I'm Eric Schiff, Director of the Center of Excellence in Environmental and Energy Systems at Syracuse University. Dr. Karma Sawyer will be presenting at our forum today on opportunities in decarbonizing buildings through controls and electrification. Her talk was invited through a new Energy Program Innovation Cluster project, EPIC project. It's a collaboration with Syracuse University and Center State CEO, our regional business organization. The project is supporting companies developing energy hardware products and systems for buildings with an eye to increasing electrical grid interactivity, to addressing equity and health in the built environment. The project itself overlaps the subject of Dr. Sawyer's talk almost perfectly. We'll send a web link for those of you interested about the EPIC project through the webinar chat facility shortly. So now let me turn to introducing our speaker, Karma Sawyer. It gives me great pleasure to introduce Karma. She's had a fascinating career over 2 decades in science and technology. She actually had a wonderful start to her career with a summa cum laude degree in chemistry from, Syracuse University. Karma next did her doctoral research in chemistry at University of California at Berkeley. She studied chemical reactions using ultrafast pulses of infrared light. But in her postdoctoral work there, she began an interesting transition from a laboratory scientist to a science and technology manager and visionary. Among other projects, she explored the economics and technologies for direct capture of carbon dioxide from the atmosphere. Her next step was to join ARPA-E as a fellow of the American Association for the Advancement of Science. ARPA-E is the Department of Energy's Advanced Research and Project Administration and was envisioned as the energy agency similar in spirit to DARPA, which is the defense agency sponsoring high-risk, high-return projects. I'm a bit jealous of Karma's timing in joining when she did. I joined ARPA-E later, a few years after she left. Her time there was closer to what is recalled by ARPA-E people as the heroic age when the agency was actually founded. So Karma left ARPA-E and became a member of the Building Technologies Office in the Department of Energy, which is essentially the capacity she's built up since then in building technologies. She had several capacities at the Building Technologies Office, managing projects in emerging building technologies and envisioning new programs to accelerate advances both for technologies and for market adoption. And about a year ago, she moved from Building Technologies Office to the national lab that I mentioned, Pacific Northwest National Laboratory, as the Director of Electricity Infrastructure and Buildings, the division thereof. So as I mentioned previously, Dr. Sawyer's talk is entitled Opportunities in Decarbonizing Buildings Through Controls and Electrification. Following her presentation, we will have a question and answer period, expected to run 15 or 20 minutes. Please submit questions using just the chat to all function in Zoom. Karma will probably have that off during her talk, so she won't be seeing those questions then. We will curate and select a few of these questions, and I'll pose them directly to Karma orally after her presentation. Okay, so I'm delighted to have had this chance to introduce you, Karma, and welcome virtually back to Syracuse, and I'm looking forward to your talk.
Thank you, Eric, and thank you for the invitation. I really do have a soft spot for upstate New York. I visited with my family for the first time in a very long time over the summer. I got to show my young children around campus, so that was just a blast. But in all honesty, I think that upstate New York is just a wonderful place for science, for innovation, and I'm happy to be able to take some time today to tell you about the work that we do at PNNL and how it might be useful for the work that you're doing upstate in advancing common goals. So let me go ahead here and share my screen. I should be able to get it on here shortly. Okay, can you all see my slides? I'm gonna assume the answer is yes. Someone will stop me if I'm wrong. Great, awesome, cool. Okay, let's go ahead and launch into this. So PNNL, Pacific Northwest National Lab, it is one of 17 national labs with the US Department of Energy. I really think that the DOE National Lab system is a fascinating part of kind of the science and technology infrastructure of our country. The system grew out of the Manhattan Project, and it really created this unprecedented capability that was required to design and build the first atomic bomb. Los Alamos, Oak Ridge, and Hanford, which later evolved into PNNL, were created for that initial mission. And as DOE's mission evolved to include applied energy research, like the work that I'll be talking about today, the network of labs evolved as well. So today, as I said, the complex consists of 17 labs, and it covers just an incredibly broad range of missions. For those of you that are less familiar with the Department of Energy, I've taken to calling it a bit of a Frankenstein agency because it covers such a breadth of work, from scientific discovery to applied research in energy, national security, as well as environmental stewardship. And so every lab in this network has a unique tools and facilities and projects, but they also engage in really cross-cutting research, collaborative research. And that's what I think is so interesting and exciting about having this infrastructure at the as a part of the United States. And so towards the end of the presentation, I'll take some time to talk to you about opportunities to partner with the labs and our mission around technology transfer that I think would be particularly useful for all of us kind of working on this joint mission towards building decarbonization. But a little more about PNNL. Our main campus is located in Richland, Washington, but we have offices in Seattle, Portland, Sequim, Washington State, and in Washington, DC, which coincidentally is where I'm located. There are 5,000 employees, scientists, engineers, and support professionals at the lab. The scientific foundation of much of the research at PNNL takes 4 forms: it's chemistry, earth sciences, data science, and biology. And that really forms the foundation of the more applied research that we do in the environmental and energy space around decarbonization and also energy storage, as well as our mission in national security. And to give you some additional sense of scale around the lab, in addition to the 5,000 staff, you can think about the lab as having spent $1.1 billion in 2021 and having over 1,200 peer-reviewed publications during that time. So I'm going to switch gears a little bit now and talk to you about PNNL's work in applied energy research. As a federally funded R&D organization, we think quite a bit about how our technical expertise and work can be used to support the mission of the administration. And in the case of the Biden-Harris administration, the climate principles are summarized in this platform called America's All-In, which lays out 3 principles of all-in climate action. If you haven't heard of America's All-In, I recommend that you look it up. There's a really nice kind of high-level summary around the way that some of the analysis actually foundationally done through some of my colleagues here at PNNL have allowed the administration to come up with these pillars that they're using to have a pathway towards actually meeting these incredibly aggressive decarbonization goals. Principle 1 of this action is to accelerate towards 100% clean electricity. So this is decarbonizing electricity and other energy supplies. Principle 2 is going to be the one that we'll be digging into in more depth today, which is decarbonizing end uses. So once you have a decarbonized source of electricity, we look at transportation, of course, buildings and industry, and think about ways that we can use those sources to decarbonize. Because of the nature of the variable renewable generation that's coming online quickly in this country, this decarbonization approach really hinges on electrification and energy efficiency. And the third principle of our all-in climate action strategy is enhancing ecosystems through carbon storage and other natural potential in our environmental space. But if we dig in more to that second principle, specifically around buildings, at PNNL, we decided to really lay out how we imagine that might actually look. What might the future of the built environment look like if we're successful? And we think there are 3 foundational principles, and I'll use this as a way to organize my remarks. First, the future of buildings are carbon-free. They're also healthy and they are equitable. And for for thinking about buildings as a part of a larger energy system, we also want to talk about future buildings as flexible, which means they're interactive with the grid and they're resilient. All of these are really interconnected, and you'll see that when I go through some of our examples, but I think it's an important framework to go back and think about. And the other thing I wanted to highlight, we're at this kind of high level framing, is that the point around equitability really has to be cross-cutting around all of these pillars. We need to have built environments that are accessible for everyone in this country, regardless of resources and where they sit. We need that to be able to meet the administration's climate goals, to get to actually net zero carbon. But we also need that to be able to ensure that this larger system provides the types of resilience and equity that's necessary for us to have the energy services we need to live healthy and productive lives. So I'm going to start off talking to you actually more in the policy space, because I think this is an important framing to understand how some of the new technologies that we develop at the labs and universities and small businesses could be utilized. And I wanted to point you to an announcement made by the Biden-Harris administration just in January. I believe it was the end of January of this year, where PNNL joined with the White House and with the Department of Energy as champions for building performance standards. And so if you're not familiar with the building performance standard, it's a policy that requires building owners to meet performance targets by actively improving their buildings over time. Many experts who work in buildings believe that without federal government leadership around the building performance standards, it could take many, many decades to transform the existing US building stock and actually achieve the performance we need for decarbonization. So current energy codes and standards apply to new construction or major renovations, and they do really help drive efficiency and other benefits. But the vast majority of buildings in America are not new. And that's certainly true in places like upstate New York and throughout New England. These are old neighborhoods with old buildings. And as a result, they do not have to meet performance standards. And so this represents a huge opportunity for saving energy and decarbonization, but also for improving occupant comfort and health. So a number of states and cities have taken the initiative to establish BPS policies for existing old commercial and multifamily buildings. And meeting those standards typically requires some level of replacing or tuning buildings' operational equipment and systems, such as heating and cooling units. And again, this is to comply with those performance standards that are laid out in the BPS. So the announcement that the White House made in January was to create a National Building Performance Standards Coalition. And they provide funding for this effort through the bipartisan infrastructure law. This coalition includes right now 2 states and 31 cities that are pursuing BPS strategies in their regions and their communities. And it encourages participants to develop and enact policies by Earth Day 2024. The administration foresees this BPS implementation providing this wide range of benefits, including consumer energy cost reductions and occupant health improvements. The Department of Energy's Building Technologies Office is a partner in this coalition, and they tapped PNNL, as well as our colleagues at Lawrence Berkeley National Lab, to provide technical support and resources to all the participants and to help accelerate and expand the coalition objectives. BTO is further identifying private sector technical support to assist cities and building owners. So there is a ton going on in this space. Here are the states and the cities that have currently adopted the BPS policy. You'll see New York City highlighted there. New York has actually been one of the leaders on BPS for the last few years now. But I just want to, nail this piece because I think it's really important to highlight what this actually means for all of you. If you're working in upstate New York, you're working in New York State, or in any of these other places in the country and trying to understand how policy could impact go-to-market strategies. Well, in short, it's a really big deal, and it will absolutely impact what is happening in the built environment in areas that become part of this coalition. It's a market pull, and I would encourage any company that is in New York State or in other areas where there are communities that are a part of this coalition. If you're working on technologies that are relevant to building decarbonization, learn about the building performance standards. The plan here is that in 2 years, over 30 cities and states will will have pledged to adopt this policy and regulate existing building performance. And as I said, New York City has been a leader for a few years now. Its initial performance requirements actually go into effect by 2024. They're some of the earliest ones on the list here. But NYSERDA has also identified the carbon neutral buildings roadmap, a call for building performance standards. This is part of their goals, and it's directly aligned with the electrification strategy. So you can think of this building performance standards as really going hand in hand with this electrification and efficiency strategy that I called out in the America's All-In approach. Of course, there is, I call kind of an elephant in the room. We talk about things like electrification and decarbonization in the built environment, and that is advanced controls. And advanced controls is really a foundational technology to making all these pillars around building decarbonization work. And PNNL has been a leader in advanced controls for buildings for many years. Some of the work that we've done for the longest has been in commercial buildings, where we've been showing opportunities to reduce energy costs and peak loads by up to 20%. But we've been doing more and more work around existing homes, looking at pretty significant reductions in peak loads, targeting those 120 million existing homes, as well as more and more field validations around individual technologies that can provide the type of grid interactivity and electrification opportunities. So those might be connected water heaters or mini splits. All of these things are areas where there's an opportunity for advanced controls developed at PNNL to be tested in real environments and actually moving into the market in a big way in the next few years. So I'm going to switch gears now and go into a little more detail about some of the specific projects that we work on at PNNL to give you a sense of how some of these things actually get operationalized as we projectize some of our work. So the first is one I wanted to highlight for you in this framework around future buildings being carbon-free, and again, carbon-free for everyone. A great example of that is the work that PNNL does to support the Department of Energy's E3 initiative, where E3 stands for energy, emissions, and equity. In short, this is an effort to make it easier and more affordable to install high-performance heat pump solutions. PNNL leads the residential HVAC smart diagnostic tools campaign, which is a part of that E3 initiative, and it helps contractors commissioning new HVAC systems to more efficiently identify malfunctions that can reduce performance in existing systems, again, through the use of smart diagnostic tools. This campaign serves as a national platform for sharing information and recognizing successes with a lot of key stakeholders working in the built environment. So contractors, installers, equipment developers, trainers. There's opportunities to work with this campaign if you have any of those hats on. So if you're interested in participating in the E3 initiative in any of these capacities, you can absolutely reach out. You can reach out to me directly and I can put you in touch with these folks, but there is an email address specifically for the Department of Energy folks working on E3, which is e3initiative@ee.doe.gov, and I can put that in the chat for y'all later. But some of the research that PNNL is doing in support of the E3 initiative is really focusing on heat pump water heaters. So I wanted to go through some of the lab and field studies that we have underway to give you a sense of the work. So we started in Portland, Oregon with a field study of 150 heat pump water heaters using the CTA 2045 shed command. And so we were really looking at two different approaches to managing loads with these water heaters. The first is to use a targeted strategy, which means our researchers at the lab actually look at the data from the homes and bucket them around, are these high users or are they low users and at what time of day, and change the load shifting strategy accordingly. So it's actually the researchers making those decisions. The smart strategy is actually using an algorithm to do that by itself and trying to optimize the load shifts accordingly. And what we've found is that the kind of more hands-on approach with the researchers doing it manually was more effective during the evenings, but the smart strategies worked better in the mornings. So we're trying to dig in and really understand what's happening within that algorithm to be able to explain those results. In our Southeast studies, we did lab testing around a lot of different manufacturer heat pump water heaters, and we're able to show that they can provide large and dependable load shifts. But what the graph here on the bottom right shows you is that we looked at a lot of different manufacturers, heat pump water heaters in different sizes, and using that same CTA 2045 shed command, and found that the reactions are different. So we need to think about how they might aggregate up as a way to provide signal to the grid in a way that might look different than you might assume if you were to take any one of these manufacturers' equipments and assume that it was typical. Right now for this study, where we have a field study of 40 homes underway with these different heat pump water heater technologies being investigated. And finally, in our lab homes in Richland, Washington, we've also been looking at some of the low GWP refrigerant heat pump water heater technologies. And we're able to find that the R1234YF refrigerant, which is lower in its global warming potential, was comparable to R134A in both summer and winter season. And our field studies of these water heaters in occupied homes over the last 18 months have shown no technical issues either. All of that, of course, is great. Exactly what we want to hear. So I want to switch gears a little bit and talk to you about some of the work that we've been doing in healthy buildings and ways that you might be able to think about this, kind of these non-energy benefits and their intersections with some of the work we do in the energy space. So PNNL led a study to investigate how COVID-19 is transmitted in office buildings. This is a study that involved releasing a benign particle that was actually designed by some of our chemists at the lab to mimic the size and the density, other properties of COVID-19. And the researchers tested how these particulates spread into offices through the HVAC system, depending on filtration, airflow, and the availability of fresh air and humidity. And they were asking questions like, can these COVID-19 particles transport through HVAC systems to connected rooms? And if they did, what's the infectivity rate between those connected rooms? This study was done kind of pre-Omicron, I think pre-Delta, so just take that as a bit of a caveat around infectivity. But then the next question for those of us who work in the building space is how the HVAC operating parameters affect those risks. So this was a study that was done both in modeling capacities as well as experimentally. And the key findings from the work found that the aerosolized COVID-19 particles do travel through HVAC systems, and that infectivity risk is greater than 0. And if there's more outdoor air and better filters, there's lower risk. But of course, that leads to energy penalties and possible system failures. And so I think this is an important thing for us to really spend some time thinking about when we think about what equity and health and comfort looks like for people in our buildings. I often find that I need to remind people that buildings actually do exist for the people who live within them. And so we need to operationalize them both to decarbonize, because that is a huge risk to human beings as well, to not decarbonize, I mean, and to be mindful of the importance of the energy services provided by HVAC equipment and lighting, and how changing one in service of optimizing the other could have unknown non-energy benefits that could be not what we might be shooting for. The optimal mitigation measures for the systems, the optimal mitigation measures for transmitting COVID-19 in this office building environment are really system and building and environment specific. And we did get some surprising results. For example, more airflow can actually increase infection risk between connected rooms. And so I think, again, this is an important set of questions to ask. And, COVID is not the only risk that we're trying to mitigate with HVAC ventilation. Many of my colleagues out on the West Coast often point to the challenges considering smoky outdoor air during wildfire season in much of our country, and how we would consider the air quality issues associated with wildfire versus energy use versus COVID. Again, all very interconnected, all very much impacting our decarbonization strategy as well as the well-being of people in our buildings. And the third principle that I mentioned at the beginning that I want to dig into in a bit more detail is the principle that Eric mentioned in talking about this EPIC project, which is that future buildings are going to be grid interactive and resilient. And that's great. I mean, I do believe that with variable renewables coming online, we can use buildings as really a foundational piece to having a modernized power grid that can manage large-scale electrification through energy storage of many kinds, including what you see with demand flexibility in the built environment. But it is a new technology, and seeing how we can actually execute this with real buildings at scale is going to be a challenge. But PNNL has been working in that space for some time. It has some exciting demonstrations of what it might look like. And one of those projects is a project that we've envisioned with our collaborators, Avista, and with the help of McKinstry and others, in a new development in Spokane, Washington, called the Eco District. And this has been a prototype for sustainable buildings and real-world demonstrations of energy innovations and this shared energy model. This has become one of the Department of Energy's Building Technologies Office connected community projects as well. And we're excited to see how that larger effort is going to be unfolding in the next few years. But kind of to give you some historical framework for this effort, PNNL research has been deploying and testing novel building technologies and energy management approaches at the Eco District, including some that were actually developed by PNNL and originally tested on the PNNL campus. Our contribution to the project builds on prior efforts sponsored by the Department of Energy, as well as the Washington State Clean Energy Fund, and has demonstrated that these technologies and these advanced control approaches can be deployed cost effectively in the field while delivering cost savings to building owners, occupants, and to the utility. So in this eco district, the buildings and the equipment within them can talk to one another. They also communicate with the grid to really make the best use of the existing grid, delaying costly construction to meet increasing energy demand, which of course is going to only be at risk for more of those types of construction efforts with the large scale electrification that we've been talking about recently. And ultimately, this is an effort that if it's scaled appropriately and managed appropriately, can really make energy more affordable for everyone. In the eco district, the air conditioning units have variable capacity rather than a simple on-off cycle. And that means that when the demand for electricity is high, they can run at a lower capacity, and thermal storage devices can supplement heating and cooling needs. Or the eco district could actually use the energy stored in batteries or on-site solar panels. All of these things are going to offset the electricity from the grid and again be able to manage some of these potentially costly construction needs while still meeting or even improving occupant experience. The building automation system at the eco district includes Eclipse's Voltron, which is a PNNL developed open source software platform that enables distributed sensing and controls. The Voltron platform has been installed in 16 campuses on PNNL's main campus in Richland, Washington, along with a network of 10,000 sensors. And this allows PNNL to reduce its energy costs on a regular basis, but it's also going to be the framework and the foundation for longer term efforts that the lab has to be able to reach net zero carbon, net zero emissions in future years. And we're really looking forward to be able to take this foundation that we've built on our campus with Voltron and be able to expand it even further. Some other exciting work that we have done in the built environment has actually been looking again at that existing buildings market, which, as I talked about at the beginning of this presentation, is just going to be critically important to meeting national decarbonization goals. And some of the most important spaces is actually in existing homes. Most of the building performance standards work that I mentioned earlier is targeting commercial and multifamily buildings. And so there are 120 million existing homes with leaky windows and legacy devices in them that are not going to benefit from that policy. As much as I think the policy is excellent, it's just not targeting this market in particular. And it's critically important that we target this market. So we have had this project that we've been doing in partnership with ecobee, Shifted Energy, and the University of Oklahoma for the last few years now. And we've been able to demonstrate 25 to 79% peak load reduction on legacy equipment. This is work that's been done in the labs at PNNL and at the University of Oklahoma. And that's really, really exciting because, again, this is a massive market with huge needs on terms of reducing carbon and energy costs. And right now we're ready to go to the field for real home testing. So if you want to dig into this in a little more detail with the images on the right-hand side, you see the graphic at the top is really communicating the ultimate vision for the connected home with control of all sorts of different appliances, all of which could interact with the grid. However, for this connected homes project, we really focus on thermal loads, so air conditioning, heating with heat pumps or electric furnaces, or of course, water heating. That's the other one we've looked into. And the graphic on the bottom shows you some of our initial work. Again, this is focused on air conditioning. The energy impacts, which are shown in green, really are fairly negligible, but we're able to get demand reductions shown in orange to 46% reduction for an indoor and outdoor temperature difference of 20 degrees F. So we've been really excited to see these types of results, and we're hoping to get this into the field really soon so we can keep moving towards making impact. So, PNNL is doing really important work here in advancing our decarbonization goals. There are a lot of innovative building technologies, many of which are in the control space that can be really impactful towards using electrification and energy efficiency to be able to meet those decarbonization goals. We are really spending a lot of time thinking about how those technologies can get into real buildings. We want partners to be able to participate in demonstration projects. And I think I'm going to switch gears shortly and talk about our technology transfer mission. But, our perspective here is, we work to advance the goals of the Department of Energy, and the goals of the Department of Energy is to save a lot of carbon really quickly, and we need to get these things into real buildings to make that happen. And there's a huge opportunity to be able to use these controls technologies to advance grid interactive buildings, to strengthen the broader energy system, but also to ensure that our buildings are providing clean energy and healthy, comfortable buildings to everyone. And we really believe that because our focus for so many years has been on affordability, there's an opportunity to do exactly that. So I'm going to switch gears now yet again and talk to you about how you can join us in meeting these important goals. The PNNL has a specific mission around technology transfer. This is true of the Department of Energy labs more broadly, where we have innovations that we develop at the labs that are developed with the goal of solving national problems and improving US competitiveness, but they can only do that if they leave the lab. And so we're looking to partner with industry, to partner with academia to make that happen. And we have a lot of innovations that are ready to go right now. There are more than 200, according to my colleagues in our technology deployment office, there are more than 200 technologies spanning multiple different industries that are ready to go and ready to be licensed. Some of those are in the built environment, others are in security or energy storage or the power grid. But there are lots of opportunities to be able to leverage these, again, kind of translating some of these innovations to different markets and different sectors as well. So there's a lot of opportunity for creativity here. I pulled some of these examples again from my colleagues in the technology deployment office to give you some idea of the types of work that we have ready to go or have been transitioned from the labs to industry. So I'll just highlight a few of them. So up on the top left, you see the shoe scanner technology, which is a next generation millimeter wave imaging scanner. This was recently licensed to Liberty Defense Holding, and it would allow airport security checkpoints to screen passengers with their shoes still on. Then in the middle of the image here, you see an IR cell. This is a rapid, highly sensitive chemical analysis tool for nuclear weapons and disease detection. It received the R&D 100 award in 2017. And then in the bottom row, here in the middle, you see the Mark Cool Chiller. This is a little bit closer to the type of work that we do in the building space. This is a cooling technology that operates on waste heat from power sources, so it's a bit higher temperature, and it's been developed for the Navy. But at a higher level, to give you a sense of the scale of how we operate in terms of technology transfer, in 2021, PNNL received 3 federal laboratory consortium awards around technology transfer and 3 R&D 100 awards. We've had a total of 98 FLC awards since 1984 and 119 R&D 100 awards since 1969. We had 46 licenses and options in 2021 and 247 invention reports. There are currently 102 active businesses with roots with PNNL, and we're really proud and excited about that. One of those examples is actually in the building space. It is GreenPath Energy Solutions. GreenPath licensed a PNNL developed easy to use sensor technology that makes it possible for anyone to identify energy savings opportunities in small commercial buildings. This is called the sensor suitcase, as you can see in the image here on the slide. So we licensed to GreenPath Energy Solutions in 2017. They won one of those FLC Excellence in Technology Transfer Awards in 2020, and are still actually working with them with a Technology Commercialization Fund Award to continue to develop and to deploy the technology in commercial buildings. They do have a commercially available product, so you can look it up at greenpathenergysolutions.com. But this is just one example of the ways that we can work together. There are opportunities like this one to directly license IP, but we can also talk about sponsored research efforts, collaborative research efforts, and facility use agreements. We try really hard to make it easy for these type of collaborations to take place. So I hope if you're curious about any of the work that we've been talking about, you take me up on that offer. We do have a simple licensing process at the lab. So if you can identify patents or copyrights the license, you can provide us with a very general business plan, and we can provide a draft non-binding term sheet and finalize some commercialization terms. It's that simple, right? Easy peasy to be able to review and then finalize a full license agreement. With a later touch, though, we also have an exploratory license agreement that we call a test drive. And then we can use a 6-month research license, which has non-exclusive options for patents and copyrights, and you can choose from hundreds of technologies and software tools. Very simple terms here. It's a nice way to kind of dip your toes in the water around working with PNNL. And I don't know if other labs have this option, but we certainly do. And then finally, we have this effort. It's the lab partnering service. So you can go to labpartnering.org, which provides quick and searchable access for thousands of available intellectual property assets, gives you an opportunity to find experts at the national labs and to discover opportunities for partnering with us. Again, in a lot of the different ways that all the projects actually I showed you before involve partnering out the wazoo. It's kind of the way that we do business anymore. So we're always looking to explore more of those types of opportunities. And I hope you take some time to poke around here at the labpartnering.org website and see if you can find something that might be helpful. But in a more general sense, here is my email address, karma.sawyer@pnnl.gov. I'm available. I may not be the person, I'm probably not the person that you would end up spending your time working with, but I can certainly get you to the person that at PNNL that might be able to help you, and I'm happy to do that. So Eric, I am about good here with about 20 minutes to spare. So I will go ahead and end the show and see if we've got some questions.
Fantastic. Thanks very much, Karma. If you'll unshare your slides, we'll be good. Okay, there you are with your non-residential environment behind you. Okay, let's see. I'm going to pick a quick question that we prepared in advance and then look more carefully. We'll look more carefully at what's come in. Okay, so you mentioned in passing, this question actually comes from the EPIC team. So addressing energy equity in low-income communities is a key goal of DOE and your organization in particular, and also Syracuse. What are your thoughts on technology innovations that might be impactful for low-income communities, especially when we loop in public health as well as energy considerations?
Yeah, this is a great question, and it's hard, to be honest. I think that the
I'm sorry.
Yeah, no, it's okay. If you can start with something hard, I can take it. So, to be honest, I think our community working in clean energy hasn't taken this challenge as seriously as they needed to for many years. And we've spent a lot of time at the lab trying to talk to these communities and get a sense of what they need in their buildings to be able to feel that they're serving their needs. I really do think that it's important to push people to remember the purpose of buildings is for people to be comfortable and to live their lives in the way that they deserve to live. Very often what we hear is, can you fix the hole in my roof? Or the hole in my window, because I really don't care about my heat pump technology. That's kind of the more immediate challenge. And so I think we need to recognize that, and there are opportunities, I think, to partner with kind of entities that actually focus on affordable housing challenges, and think about if there are cohesive solutions to maybe not push the most state-of-the-art technology, fix these people's roofs, make their houses safe, and make sure that they can focus on feeding their families. And then you're going to have, I think, a more productive conversation about a heat pump or a control technology or a storm window that you could install and be able to continue them on this path to having a better and better place for their family to live. But I think if you skip some of those early steps, it's going to be a pretty futile conversation. That being said, I think there are other efforts that are worth highlighting. PNNL is a partner on a recently launched project called Energy Storage for Social Equity. I can see if I can find a link to share with you all for that. That is actually work that's sponsored by the Department of Energy's Office of Electricity, but has been investigating ways to do technical assistance where energy storage can be deployed in communities to be able to add to some of the resilience needs that they might have. And I think buildings are a piece of that. I mean, this is not a buildings project in particular, but the electricity that is being stored is often used to be able to condition people's homes. And I encourage people to think about kind of the intersections of these areas. If we had better insulated homes, if that roof didn't have a hole in it, that energy storage would be operationalized in a very different way.
Okay, here's a question from Charles Bertuch, one of the listeners. I'm just going to read it verbatim. Speaking of equity, could you comment on the cost to consumers due to real-time pricing, which is necessary to drive smart appliance load management? And the example is the Houston power outage last winter. So yeah, I hope you can follow that question.
I can follow that question. I'm not sure that I mean, I can opine on many things. I don't know that it would be terribly useful. You know, I think it's something that we do need to be mindful of. Real-time pricing, and certainly the example in the Texas power grid issue, is one that is an important one to be able to be realistic around. There are efforts that if they are deployed without being mindful of the impacts on consumers, might seem marginal in most circumstances. But when you think about extreme events, which will become more and more prevalent, they could have really negative consequences on the people that are most vulnerable in those circumstances. Certainly, real-time pricing is one of the policies that we need to be able to understand, and I think research those implications. PNNL has a long history of working on transactive energy. Transactive is ultimately an economic framework to be able to allow entities to bid in and say what they're willing to pay for energy services at any given time. Most of that work is framed again around commercial buildings, not consumers, but the framework could be applied more broadly. And I think you can imagine those types of policies and frameworks being developed in such a way that is mindful for the impacts on individual homeowner in a way that's very different than for a manufacturing plant. But I think we're in the early days of figuring out exactly how those policies would need to be developed. And there's a lot of opportunity to ask some hard questions and push ourselves to think about the best way to implement them.
Okay, thank you. Here's another one. So you mentioned the COVID-19 transmission studies, and someone has actually asked that we post a link to that report. But in the same spirit, there is this sort of trade-off between indoor air quality and health and the energy and other costs. And what is the thinking, of you and your colleagues about how that trade-off could be best managed. So, anyway, why don't you tell us what you guys are thinking?
Yeah, well, I think, that's the study is kind of our first opportunity to kind of answer that question. And I think what it comes down to is we have a lot of variables that we need to be optimizing. And there are going to be some campuses, for example, that have critical loads. You can think about hospitals, for example, and just keeping the lights on all the time is the top priority. Emissions and things like that are lower. But ultimately, we have multiple objectives we are trying to optimize for. And I tend to think about it as a Pareto front, right? Where is the Pareto front around indoor air quality, emissions, cost, equity, and how do we kind of weigh all of these things? So I don't have a clear answer for you because we're still thinking about, okay, what are even all those variables we need to consider? And it's a very situationally dependent. If we're not in a pandemic, we're not talking about indoor air quality the same way. If we're not in a wildfire season out west, we talk about it differently as well. I think a lot of it is coming down to developing best practices for what these operational frameworks might need to look like in each of these different cases, and changing them as we need to. But as variable renewable comes online, as we have more and more energy storage, and as we have the ability to deploy advanced controls at different times of the day, utilizing thermal storage and these other DERs, the opportunity space to actually solve these problems is just far, far wider than it even was a few years ago. So I tend to think that this is going to be a place where energy storage is going to be a key technology to be able to just give us more kind of space to play in the areas where we just have a higher demand because of whatever the air quality issues might look like.
Right. Well, I'll use my privilege as the moderator and pursue that just one more level. So we talk about grid interactivity, electrical interactivity, and what I've been pondering is the possibility of, if you like, pandemic interactivity, which is too short that the county health commissioner declares a level blue or a level red flu emergency, forget COVID for the moment.
Yeah.
Then the buildings could automatically adapt to that. Is that something that PNNL and you and your colleagues have been thinking about?
It's certainly something I've been thinking about, and we've been talking about through this framework of kind of what are the different considerations we would need to optimize for. I've thought of it to some extent around pandemics, but you can see, I mean, in the Pacific Northwest, we had this big heat dome last June, right? And
right.
That we have all of these different kind of relatively short term, right, on the order of a few days, pandemics, much longer potentially, that could really change the way that we operationalize things. And so, I mean, to me, that feels like a very reasonable way. Again, I think having better controls, more storage capability, more broader system level thinking about how to provide energy services under those extreme circumstances is going to be the most important thing to be able to do that. I'm actually really, in some ways, there's been I don't want to call it a silver lining, but maybe we frame it as this was, as indoor air quality is one of the things that it was not on my radar. And I worked in the building space and energy field for a very long time. But my thinking has changed drastically because it's really shined a light on the way we need to change how we operate things if we're going to be able to provide energy services. And there are probably many others out there that I haven't seen coming either. So having a framework that allows for some flexibility here is probably the best that we could do.
All right, we're drawing close to the time, but let me ask one more question. So one difficulty in financing any improvements in building systems is the short payback times expected by building managers and in the inner city of Syracuse, landlords, renters who want almost unreasonably good payback times. So as a financing issue or the policy or possible mechanisms for moderating that, yeah.
Yeah, I mean, I agree. I don't know that I have a solution. I think this is a financing issue. This is a capital issue. I also think that it's an issue of, and this is probably going to be less helpful for those renters in Syracuse. But it is an issue with actually valuing the energy services in a different way. Those payback periods are framed in a world of energy efficiency. We're not thinking about non-energy benefits. We're not thinking about health or any or climate change mitigation or any of those types of things. It's an antiquated way to talk about these technologies. It's also been done for many, many years. It's going to be hard to break people. But I think the more that we can talk about our technologies in a more holistic way, that providing more than just energy services, the better those conversations will get over time. I think in the near term, it's financing. You have to be able to find some other economic solutions, but there is a market pull opportunity here that I think has not been sufficiently tapped.
Well, it turns out someone in parallel asked another variation on that question. That's David Goldstein from a startup company. Technologies that improve occupant health don't have a payback the way energy efficiency improvements do. How do we incentivize owners, landlords, et cetera, to spend money on improving indoor air quality when there is no direct economic benefit to the building owner?
Yeah, well, it's interesting. This is where I think equity becomes a real issue, because if you talk about healthy buildings, green buildings in high-end commercial real estate, I live in downtown Washington, DC, people are able to make money on that, right? That is a different conversation. There's no benefit for landlords in lower income. And I mean, there should be, but you're right. It's not, the people that are paying the bills there aren't valuing the occupant health impacts in the same way. There's certainly something that people pay for in hospitals. So, I mean, what it comes down to is where people are actually putting money towards. And it's not shared for all members of society equitably. And we've got work to do with that space.
Yeah. In some ways, my own take is that some of these problems are going to be harder to solve than the technology ones, where we sort of are full of ideas. But
yes, 100%.
All right. I think we're sort of running dry on questions, and your time is just about up with us. So I'd like to, first of all, thank you very much for spending some time with us. It was really interesting and exciting, I think, to everyone on board. And so thanks very much. People who want to can raise the the thumbs up in their response mode in Zoom chat. We're still learning how to use this effectively. I also wanted to thank our sponsors specifically. So at Department of Energy, that's the Office of Technology Transitions, as well as the Building Technology Office. And then the Center of Excellence is co-funding some of this work through NISTAR, which is part of Empire State Development. So that's our thank yous to our sponsors. And then also, we are running a regular series of these webinars. So the next one will be Wednesday, March 23rd. Essentially, the subject will be intellectual property landscaping. We're also blessed to have at Syracuse University an innovation law center that does this with law students. And there is a budget inside the EPIC project to help with that. So if listeners or companies are interested in getting some help specifically on intellectual property landscaping or related subjects, that can be arranged at fairly marginal or minimal costs for some of you. So do approach us about that and attend the webinar and learn more on March 23rd. Okay, thank you very much. Karma's sent around her email address, and thank you very much to all our listeners and to Karma, and the recording will be made available within a couple of days.